Systems Electronics. In this video, we are going to use Thevenin's theorem to calculate for the current across the 10 ohm resistor. In Thevenin's theorem, a linear circuit can be replaced by an open circuit voltage, which is the VTH, in series with the Thevenin's resistance, which is the RTH. So with this, the first thing that we are going to do is that we are going to find the Thevenin's voltage. So in finding the Thevenin's voltage at this side, what we do is that we remove this resistor and replace it with an open circuit. So the resulting circuit will be looking like this. So with this in place, we are going to calculate for the VTH, which is the open circuit voltage. So what you realize that because there is an open circuit here, current will not flow in this direction, but then the current that is flowing through the 5 ohm resistor will be the same current flowing through the 15 ohms resistor. So the first thing we are going to do is that we are going to calculate for the I1, then we will calculate for the I2 using this loop, then we will use the resulting current to calculate for the VTH. If we are to take this particular loop, get to realize that the VTH should be equal to 15 times the I1 minus 8 times the I2. It is minus because, see, the direction of the VTH is this way, and this current is opposing the direction of the VTH, so it's going to be minus. So with that, we move on to calculating for the I1. So if we take this loop, we are going to get 4 is equal to I1 times 5 plus 15, which is going to give you I is equal to the 4 ohms divided by 20, which is going to give you 0.2 amps. Then we are going to use this loop to calculate for the I2 also. So for the I2, 6 is equal to the I2 times 12 plus 8, because the 12 and the 8 are in series, because the current will not split at this junction, but then all the current will flow through this loop. So the I2 is going to be equal to 6 divided by 20, which is also going to give you 0.3 amps. So with that, we are going to calculate for the VTH. So we already have the formula for VTH to be 15 I1 minus 8 I2. So it's going to be 15 times the 0.2 minus 8 times 0.3. So we are going to get 3 over here, then 2.4 over here. So the resulting VTH is going to 0.6 volts. With the 0.6 volts as our VTH, we are going to calculate for the Thevenin's resistance. So to find the RTH, we are going to short circuit all the voltage sources. So we are going to short circuit the 6 volts and then the 4 volts. So the resulting circuit is going to look like this. The resulting circuit is going to look like this. So what you would realize is that if you are looking through this open circuit, the 5 volts and the 15 volts are going to be in parallel, and then the 12 volts and then the 8 volts, the 12 ohms and then the 8 ohms are also going to be in parallel. So with that, the RTH is going to be equal to the 5 in parallel with 15 plus the 12 in parallel with 8. So the RTH is going to be 5 times 15 divided by 5 plus 15 plus the 12 times 8 divided by 12 plus 8. So this is going to give you the resulting resistance is going to be 171 on 20. So with this, we are going to find the resulting circuit, which is going to be the Thevenin's voltage that we found. Then we have our Thevenin's resistance over here in series with our 10 ohms resistance. So our Thevenin's resistance was 171 on 20. We had our Thevenin's voltage, the VTH, to be 0.6. So we are going to find the current that is flowing through this circuit. That will be the current through the 10 ohms resistor. So with Ohm's law, we know that V is equal to I times R. So if you want to find I, which is the current that is flowing through the 10 ohms resistor, I is supposed to be equal to the V going to. So the current is going to give you I is equal to V over R, which is the 0.6 divided by the total resistance is going to be 171 on 20 plus 10, because they are in series. So the total current is going to be 0.0323 amps. So that's going to be your final answer.